Alrighty, so in this video, we're going to continue to look at slope. Now we're going to look at something a little different. With this first one, we're going to be missing a coordinate for our slope. So we're going to go through and look at this, how to calculate this, and then we're also going to look at kind of a real world situation and analyze a little bit about what slope means and what we can identify about a certain situation. All right, so first let's go ahead and look at this problem up here. So we can see we're going to use the same slope formula we have in the past couple videos. So if you aren't familiar with slope, definitely go back, watch those videos so that you have the idea here. I'm going to walk through it pretty nicely on this one. But there's something slightly different about this one. So we have the points -8 and r, so I'm missing a coordinate there, and -5 and 11. And they lie on a line with slope 2. So I know it has a positive slope of 2. And what that means is it's going up by 2 and to the right by 1. So it's going 1, 2, 1, 1, 2, 1, 1, 2, 1. And I'm not doing that very nicely because that looks more like 2. But that's the idea there, okay? So I know that this equals 2. So slope is actually 2, and then one of my coordinates is missing. So in the previous videos, we had both full sets of coordinates and we were finding this slope. We're going to apply it very similar. We're just going to flip that around. We already have the slope and we're going to find the coordinate necessary to get that slope. So now I'm going to do the same thing. So I'm going to look at the y's and I'm going to say, well, y1 is r and y2 is 11. And I actually kind of flip that around. And I always do, this is y2 and this is y1, just to make it a little easier for subtracting. I don't have to switch the order. So I have r minus 11 over, and now I'm going to look at the x's. So I have -8 and -5, and it's -8 minus -5. Remember, this minus is part of the equation. It needs to be there, right? So both of these minuses are part of that equation. When I hear minus negative, that means plus. Whenever I hear a double negative like that, and I want to be clear, it doesn't mean if I had it like this, that's not a double negative. This is -8 minus 5. It means I had -8 and I'm going 5 more negative. The double negative is when we literally see or hear minus negative. That's a double negative. It's right back to back, right next to each other. That turns into a positive. Or if we have it multiplying, you know, -8 times -5, okay, that turns into a positive. A negative times a negative. Or if I divide by a negative like this. So those are the situations when it turns into a positive. So be careful about that because I do have students kind of switching that around. So this situation needs to equal 2. All right. So now I'm going to start to simplify. So I have r minus 11 over -8 plus 5. We can think of this as 8 minus 5, which is 3. And then we can just go back and say, which one is more, 8 or 5? Well, 8 was more, and it's negative, so it's -3. I can also visualize this with algebra tiles. So I can draw this really quick. Let's see. 1, 2, 3, 4, 5, 6, 7. So here are my -8. And then I have +5. Like that. 1, 2, 3, 4. There are my 5 positives. And when we're doing algebra tiles, remember, one negative can cross off with one positive. So I just cancel them out like this. I cross them off until I can't cross off anymore and I see what's left over. So I have -3 left over. So hopefully that idea of I have more negative than positive, when I was saying that out loud, this visually makes a little more sense now. I do, in fact, have more negatives. 8 is more than 5. Okay? So the only problem with algebra tiles, potentially, is that when we start to get to big numbers, that can be very tedious to draw. But it's very helpful for learning. It's a great visual for understanding the idea of subtracting and adding those integers. All right, so this equals 2. So now what I want to do is I don't want this side to be divided by -3, so I'm going to multiply. I'm going to undo that division by multiplying by -3. -3 divided by -3 cancels out, and I have r minus 11 equals 2 times -3 gets me -6. And now I don't want to know what r plus 11 is. I want to know what just r is. So I'm going to add 11. I'm going to undo that subtraction. So I have r 11 minus 11 cancels, equals negative 6 plus 11. So this would be very similar to the situation, except that I would have more positives. I'd have 11 of the yellows and only 6 of the reds, right? So 11 minus 6, I would end up with 5 of those yellows left over, because I can say 11 minus 6, and 11 is the bigger number, so this is going to be positive, because I have more positives than negatives. So in order for this to give me a slope of 2, which is what my requirement is, that missing coordinate has to be 5. All right, so let's see. I want to make sure. All right, so let's go ahead and look at this next problem down below. So we have finding the initial amount of a rate of change given a table for a linear function. All right, so Goran is adding water to a swimming pool, right? So here we have Goran, and I'm not very good at drawing a swimming pool, but we're going to pretend like it's rectangular here, and it's got some water in it, and it's a very small pool. It's in the background somewhere, and he's adding water to it. So I'll just do water drops to show that he's adding water. I've done that in the past. So here is my silly little visual for this situation. I have a person, he's adding water to a pool. All right, the table below shows the amount of water in the pool after different amounts of time. So after 6 minutes, there's 118 gallons of water. After 9 minutes, there's 142 gallons. After 12, there's 166. After 15, there's 190. So how much water was already in the pool when Goran started adding water? Well, if we think about this, it's not 0. He didn't start at 0, because let's look at between 6 and 9. That's 3 minutes, right? So 3 minutes have passed. How much water has been added in those 3 minutes? If we simply subtract, we can figure that out. I can borrow here. So I get 12. So 4 and 2. So 24 gallons have been added in 3 minutes. So in 6 minutes, 118 is not going to be fully added, right? Every 3 minutes, there's 24 gallons going in. So for 6 minutes, that would mean 24 2 times, because every 3 minutes, there's 24. So there's 3 minutes, there's another 3 minutes. So there's 8 and 40. So in the 6 minutes that he started adding water, he only added 48 liters, not 118 liters. That's how much is in there after 6 minutes, because we started somewhere. There's some amount that we started with. So this helps us really quickly know, okay, I didn't start at 0 then. What I started with was 118 minus 48. We need to do another subtraction here. 8 minus 8 is 0. And 11 minus 4, we get 7, right? Because we'd have take 1 away, and then we'd have 3 more and take away, which would be 7. So 70. So we started with 70 gallons in the pool. Again, we didn't start with 0, so we need to look at that relationship. And we can even test it again and say, okay, after 3 minutes here, did I add 24 liters? So I could have tested it again, but it should be, since it's at a constant rate, it should stay consistent here. So we have 4 and we'd have 2, so that's another 24 gallons. So every 3 minutes, which is what this is showing here, I'm going to have 24 liters being added. So really, I can do the subtraction here and say, okay, I know it's 24 liters every 3 minutes, and I can go, okay, well, 6 has 3 in it 2 times, so it's 48 gallons. and then subtract that from what I know he's at 6 minutes. But I could also take that table, so it's 6 and 18 like this, and I can step it back. At 3 minutes, how much would I have? And then at 0 minutes, how much would I have? So I could have done the subtraction a little different, literally by kind of extending that table off to the side here. It just depends on which method makes a little bit more sense to you. So if I subtracted 24 from 118, because when we go forward, we're adding 18, right? But if I'm going backward, I'm going to subtract 24. So that's that subtraction idea here. So if you notice, I'm subtracting 24 twice to get to this 0 mark, which would get me to that 70. So either way, I'm subtracting that 24. I can subtract it all at once by combining them and subtracting 48, or I can subtract them one at a time. So totally up to you. Got a couple methods there. All right, so now we're going to choose the statement that best describes how the time and the amount of water in the pool are related. So I'm hoping before we even start reading any of these situations that we understand as time is moving forward, as more and more time is being built up, there's going to be more and more water in the pool. They are both increasing. Okay, so that's something that I'm hoping we identify, that idea that we're adding water as time goes on. So more time means more water. So let's go ahead and read down here. As time increases, the amount of water in the pool decreases. Well, time is increasing, but we're not taking water out of the pool, so that doesn't work. So the next little bubble, and we only fill this piece in if we bubble that in. So usually the little bubble's a little smaller, but I had to make it a little bigger off to the side here so we could fit an answer. As time increases, that's true, the amount of water in the pool increases. So that is what we want. Time is going by, we're adding more and more water. And at what rate is the water of the pool increasing? So they want to know how many gallons are we adding per minute. So up to this point, we've been looking at every 3 minutes. So we want to know if it's 24 gallons every 3 minutes, what is it per minute? Basically, they're asking us to divide. Just reduce this. I want to know for 1 minute how many gallons are being added. So I'm dividing by 3 to get to 1. So 24 divided by 3 is 8. So I'm adding 8 gallons per minute. Alrighty, so that was slope without one of our coordinates, and also looking at a linear function, kind of analyzing a linear function when we're given a table. All right, go ahead and go on, Alex, and give that a try.